Welcome, students. Today we're diving into the captivating world of forces and motion. Forces are the driving factors behind the movement and interaction of objects in the universe. By understanding forces, we can unlock the secrets of how objects behave and why they move the way they do. So, what exactly is a force? In physics, a force is a push or a pull that can cause an object to accelerate, change direction, or deform. Forces can be exerted through direct contact, like when you push a book on a table, or they can act at a distance, such as the gravitational force between Earth and objects on its surface. To describe forces, we use a few important concepts. First, every force has a magnitude, which refers to its strength or intensity. For example, if you push a cart with a certain amount of force, the magnitude of that force determines how hard you're pushing. Second, forces are vectors, meaning they have both magnitude and direction. Just like with displacement or velocity, we represent forces using arrows. The length of the arrow represents the magnitude, and the direction of the arrow indicates the force's direction. Understanding the effects of forces on motion is crucial. When multiple forces act on an object, they can either balance each other out or cause the object to accelerate. This brings us to the concept of net force. The net force is the vector sum of all the forces acting on an object. If the net force is zero, the forces are balanced and the object remains at rest or continues to move with a constant velocity. However, if the net force is non-zero, the object experiences acceleration in the direction of the net force. Newton's laws of motion provide us with a framework to understand the relationship between forces and motion. The first law, known as the law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion with a constant velocity, unless acted upon by an external force. This law emphasizes the concept of inertia, which is an object's tendency to resist changes in its motion. The second law, often referred to as the law of acceleration, tells us that the acceleration of an object is directly proportional to the net force applied to it and inversely proportional to its mass. In simple terms, the more force you apply to an object, the more it accelerates. Additionally, if you increase the mass of an object, it becomes more resistant to changes in motion. The third law, the law of action and reaction, states that for every action, there is an equal and opposite reaction. This means that whenever an object exerts a force on another object, the second object exerts an equal but opposite force on the first object. This law explains why we can move forward by pushing against the ground or swim by pushing against the water. By understanding forces and motion, we can explain a wide range of phenomena, from the motion of planets in our solar system to the flight of a soccer ball. We can analyze the effects of forces on different objects, calculate their accelerations, and predict their future motion.